Okay, tan graph. Remember, tan is the slope. So at x equals 0 or theta equals 0, I have a 0 slope, so tan of 0 is 0. As my gradient, or as my x gets bigger, my slope gets bigger, until it gets really, really big, and then it gets undefined. And then all of a sudden, it's really, really big but negative, getting flatter, getting to 0, getting steep again, getting very steep, getting undefined. So you can, rather than me take up this video doing it, you can play with a table of values, but what we're thinking here is there's x and there's y. As x gets bigger, the slope gets bigger until it's undefined. And then it's very steep but very negative, and then it gets to 0 again, and then it starts to get steeper again until it's undefined. After undefined, it's steep again but negative, and you can see the pattern. Can't go back any further. So that's the tan pattern. Realistically, y equals 10 tan x. It still just looks like that. It's just a bit steeper. You still have the same asymptotes there. It would just go like that a little bit more. Yep. Again, you can play on Desmos, you can play with your table of values, but that's the basic tan graph. You can put coefficients of x in there. So if you had y equals tan 2x, then your initial asymptote used to happen at 90, or if we, in radians, it would be pi on 2. But now when x equals 45, 2 times 45 equals 90. So that means instead of that first asymptote happening at 90 degrees, it would happen at 45. Or if we're in radians, it would be pi on 4. But it's still going to look like that, but that coefficient of x talks to you about where these asymptotes are. Okay, that'll do on tan x. Please jump into Desmos and have a play, or table of values.